whether V and W are equivalent vectors, we have to find their component vectors and find their magnitudes. So what we're going to be doing here is just the same math that we were doing before and lots of practice with it. Okay? Trying to get you to practice math. You don't have to practice later. So I'm gonna ask you to work ahead if you can. Find this component vector, find V and its magnitude. And then do the same for W. And maybe we won't do all three. And if everything's the same, then they're equivalent. If you have the same components and the same magnitude, then you have equivalent vectors. If you don't have the same components and the same magnitude, then they're not. So for V, I'm going to do -5 minus 1, -5 minus 3. And I'm going to write it out because writing it out really helps for me to just get it into long-term memory. -6, -8. And you don't have to worry so much about magnitude because I think for a couple reasons. One, magnitude, really, you're just using the Pythagorean theorem. You guys are really good at that. Secondly, the magnitude equation is on your equation sheet. Oh, 100, yeah? Is this magnitude 10? Is that what you guys got? Lovely. All right, let's do W. -7 minus -1. And -8 minus 0. Are V and W equivalent, Tarday? Yeah, and you don't even really need to find that second magnitude. You know if it has the same components, it's going to have the same magnitude. So these are equivalent. All right, try B and C and I'll catch up with you. Be really careful with your order. Keep being careful with your order. For B, are V and W equivalent? They're going to have the same magnitude because you have the same numbers there, 2 and 4. But they don't have the same direction. You're not with these. You're not both going 4 right and 2 up. They're switched. All right, tell me what you think about C. You guys are way ahead of me, which is awesome. So for V, I got -9, -1. What did you get for W? 9, 1. So these are, again, are going to have the same magnitude, but are they equivalent vectors? No, they're directional. Awesome. Both of those magnitudes would be square root of 80. Questions so far? 500 tiny little math problems, and here are some more. So what this little box is just tells you the operations you can do on vectors. And the nice thing about vectors is the operations work like you think they should. When you're adding vectors, you add their like components. You add the horizontal components, you add the vertical components, you're done. Same thing with subtraction. You can multiply by a scalar, and you do that by distributing that scalar in. So if you wanted your vector multiplied by 5, you multiply your horizontal and vertical components by 5. All right. So, given the vectors u and v, find the following. The thing you do have to be careful about here is order of operations. So when you're working through something like -2 times u plus v, you got to add the vectors first and then multiply by -2. Okay, and when these two are very different, here you're going to subtract the vectors and then find the magnitude. Here you're going to find the magnitude and then do the rest of the math. Okay, so let's work through each little example. So -1/2 times u. U is -3/7. So the first thing I always do is just write out the problem. And then you're going to distribute in the -1/2. -2 times u plus v, so we're going to add those vectors first. So to add the vectors, we add their like components. So I'm going to do -3 plus 5. And then 7 plus 1. And I probably wouldn't write out that stuff if I was doing it. I know someone in the back was like, oh my gosh, you really have to write that? Yeah, I will. No, just do it right. -3 plus 5 is 2. 7 plus 1 is 8. And then multiply by -6. Good so far? Questions? All right. Here we need to subtract and then do find the magnitude. So first I'm going to subtract my vectors, and this is v minus u. So that order is important. 5 minus -3, 1 minus 7. So that's going to be -6. And we're finding the magnitude. I'm going to bring down this line and see where I was there. And magnitude is just square root of the squares. I think we've done that math already. Yeah, square root of 100. Lovely. So now this last one, again, careful with your order of operations. If we're going to do 3 times the magnitude of u minus 4 times the magnitude of v, we have to find those magnitudes first. So I'm just going to kind of do that off to the side here. Magnitude of u is going to be negative 3 squared plus 7 squared. Magnitude of v, 5 squared plus 5 squared. Yes, I did. So that just happened. All right, 49 and 9, 58. 25 and 1, 26. I don't think 58 is reducible. Does 4 go into 58? No. And so the way we're going to write out this answer then, 3 square root of 58 minus 4 times square root of 26. And that's all we can do without a decimal approximation. So don't be flipped out by that. Now we're going to do a couple graphs. Couple quick graphs. So I think that in the past you guys maybe you've done some graphing in physics. Have you added vectors graphically in physics? Parallelogram or head to tail? So I don't care which method you like, if you have a method you like for this. I always do head to tail method because that's what works for me and what's worked for students in the past. So if I'm going to add 2 vectors, I like to start at the origin and draw my first vector. So if I'm going to add u plus v, I'm going to start with u, and I'm going to draw it starting at the origin. So that's going to be right 1 up 5. Right 1 up 5. Those are the components. And then to do plus w, instead of starting at the origin, which is I think what you would do if you're using the parallelogram method, you start at the tail of your original guy and go whatever your directions are. So here we're going to go right 4 down 2. 4 down 2. And then u plus w is the vector that links up the start of your first one and the end of your second. So u plus w is this guy. The other thing that you can do on the quiz for me, if you would like, is add your like components. 1 plus 4, 5 plus negative 2, and get that vector. 5, 3. And that should be what we just drew. Over 5 up there. That is the plus. Questions on that? 3v. So v is this guy here in the middle. 3 of it really is exactly what it sounds like. If you want to draw the original, we're going to start at the origin. We're going to go left 2 up 3. And then 3 of it really is just 3 on top of each other, or the length of it times 3. So you would just do that 2 more times. Left 2 up 3. Left 2 up 3. Again, if you would rather do the math, 3 times negative 2, 3. Negative 6, 9 is hopefully what we just drew. I'm doing my job wrong. 6 up 9. Subtraction is a little more tricky if you want to do it graphically. What you have to do is the opposite of whatever the second vector is. Again, if you would like to just lean on the math and actually do the subtraction, do V minus W. So here's V, and here's W. So -2 minus 4, and 3 minus -2. If that works for you, that's brilliant, and I would stick with it. -6, 5. -6, +5. If you want to do it graphically, the way you do that is to start with V. So V is -2, 3 over 2 up 3. And then do the opposite of W. So W was 4, -2. The opposite of W would be -4, +2. So over 4 up 2. I think where subtraction is concerned, this is a little easier. Actually,